Hello everyone, and welcome to the DELMIA Operations World Tour 2020. My name is Fred Thomas, and I'm a Strategy and Marketing Director at Dassault Systems, and I will be moderating today's Transportation and Mobility track. Before we get started, I'd like to go over a few items so you know how to participate in today's session. You are listening to this event through your computer speakers, so please make sure that they are turned on and up for optimal audio. You will also have the opportunity to submit questions to the team by typing those questions in the box on the control panel. You may send your questions at any time. We will collect them during the session and address them during the Q&A session at the end of the presentation. I would now like to introduce today's presenters. From Dassault Systems, we have Henri Beringer, Transportation and Mobility Consulting Director, who will be talking about the importance of rail operations efficiency. Then we will have a customer case study on Swiss railways presented by Rene Moraske, Senior Project Manager in IT from Swiss Railways. Following Rene, Henri Beringer will talk about the DELMIA solution for rail operations. And then we will end the day with our Q&A session. Gentlemen, the session is yours.
Hello everybody, so welcome to this session about rail operations efficiency. I'm very happy to have Rene Moraske from Swiss Railways with me today. I'm Henri Beringer, and we'll go today through three parts in this presentation. One will be, I will just give you a very quick overview of why it is important for rails to focus on efficiency of the operations now. Then we will deep dive, thanks to Rene Moraske, on the SOPRE project regarding the resource planning at Swiss Railways. It will be very interesting. And then I will give you an overview of the solutions from Dassault Systèmes and from DELMIA and DELMIA Quintic for rail operations efficiency. So first, why rail transport is important? I mean, maybe it's obvious for most of you around, but I mean, we know we are suffering urbanization, problem of infrastructure saturation. We know that mass transport remains the most efficient way to occupy to move people around with a minimum use of the infrastructure, very limited space, and minimum pollution. It's not that easy. There is a lot of alternative transport systems, and but rails remains the backbone. We know that we need to urgently organize better mobility in general and to make it safe, shared, and sustainable. That's really the motivation. So rail is the backbone of that. And if we deep dive on that, we know the major reason is the energy efficiency of rail. If you look at the different type of rail of mobility systems and means, you see that the energy required for cars or aviation is much bigger than rail. So the only competitive means maybe walking and two-wheelers, but the rest is much more energy intensive and pollute a lot. So we see a lot of energy in the world to continue to develop and expand the rail. This can be seen in, for example, especially in both urban and high-speed rail. The biggest countries are China, European Union in general, India, Japan, and Russia. North America is a little bit behind. There are massive investments for developing railway infrastructure. 400 billion per year of dollars are spent to develop this infrastructure. But at the end, rail mobility remains only 10% of the total mobility. So it's interesting to see that, well, to attract people on rail remains a fight, and despite massive investment, there must be other elements to do. You see that the countries, many countries are indeed focusing on developing rails. Maybe the most striking ones is Germany. So as said by the Ministry of Transport in Germany, Germany has been a car country with fantastic motorways, Autobahn, and now the focus is to develop rails. And this is because of climate goals and to reduce pollution. And you see the very ambitious target for 2030 to double the number of passengers per year, and to also increase freight transport by 70%. So big ambitions, a lot of money on the table to do that. And this is only one example. France has similar type of strategy. Switzerland has been always very adamant on rail, has made a lot of effort in developing freight on rail, for example. So this is a general dynamic. We see also India investing a lot. So the thing is, as I said, there is a lot of investment on infrastructure, but that doesn't give immediately efficiency and attractiveness that is needed. So you need to be sure that if you have an offer, people will choose rail for their transport. So for that, operations need to be very efficient. And they need to be efficient for the quality of service. They need to be efficient to offer as best possible a good minimum transit time. You will not take rail if it takes a double of time than the mode of transport, and also to control cost. And we all know, we have all suffered perturbation in rails. We all know that it could be big perturbation, a lot of delays. There have been some bad years, for example, in 17 in a French metro, awful 30% of train being late, RER, it's a fast-speed metro, so imagine 30% of your time you go to work and you are late because of the metro. It was not good. So that is really a problem to be addressed. And what are the different means for that? There are automation. Automation is certainly a big dynamic, and we'll speak a little bit later on that, of train control system and automatic operations. Also, and train control system, you will see has also impact on capacity. There is then the health of the infrastructure and of the rolling stock. If assets break down too much, you have a problem of variability and availability and quality of service. And last but not least, because it's the core of our presentation today, you need to better plan and optimize the operations. So just about advanced train control systems, this is an important domain in rails with the deployment in metros of communication-based train control, which allows fully automatic operations and a lot of big throughput. We have the ERTMS, European Train Traffic Management System, which allows, in theory at least, interoperability across the different countries with semi-automatic traffic regulation system, which increase capacity and also increase interoperability, which means that you can go across borders more easily, and also increase capacity. And you also have some deployment in the US, but only focused on safety, but which are important ones. So all those different controlling systems are very important, have to be deployed. It's still ongoing. It will last for a long time. It's also an element of perturbation because it requires blocking the infrastructure in some cases to do those deployments. So this is one aspect. Another aspect is about maintenance and to be sure that assets are available and healthy at any time. There is a big trend here, which is that we have now more and more data about those assets. If we focus on the rolling stocks, more and more rolling stock have sensors and are connected that can give information about their health. And that allows to change the way maintenance is done using what we call condition-based maintenance or predictive maintenance, even there, which is basically based on the information we get out of the sensors. And if we put in place an efficient collaboration between train manufacturer and operators, we can win a lot of efficiency there by using those data, between 50% to 25%. We'll see that later. Now, operations efficiency, the planning of operations is very complex a problem. Why is that? In rail, there are a lot of constraints which are tightly coupled. The first one coming from the infrastructure. At infrastructure level, is infrastructure available? How do you make evolution to it? We just saw how you make evolution, so the signaling parts. And when do you decide to maintain? Has a lot of impact on what are the services you can offer on this infrastructure, what are the routes you can take on this infrastructure, what is the timetable that you can offer, how can you connect better at stations and offer more connections and efficient connections. And then all that influence a lot also the fleet plan, which unit, which locomotive can be used for a given service. And last but not least, this also influence a lot how who should drive the train, who should be on the train, which crew, and how can it be there and offer the service. And all that is very, very complex, also in terms of numbers. We see here an example of a European operator. You see that, for example, they have 10,000 rolling stock units to manage, and nearly 20,000 drivers, and plus 15,000 other crew. So it's huge, it's complex. And when you look at crew, you will see being the last, it's the most complex because most often perturbated. So we will focus today, and this will be the presentation of SBB, and from we will see just in a minute how we can do that. So this is it for the introduction. I'm happy now to have our friend Rene from SBB speaking about the SOPRE project that has been done there.
Okay, my name is Rene Moraske. I've been a senior project manager at Swiss Railway for 12 years. And since 2015, I've been responsible for the integration of personnel planning into the DELMIA Quintic solution. First of all, I would like to introduce the SBB to you.
More than 100 years ago, the pioneers of SBB revolutionized mobility for all of Switzerland, one step at a time. Since then, it's been full steam ahead as we've developed and electrified public transport. We simplified timetables in 1982. We became a public limited company in 1999 and reached a historic milestone with the Rail 2000 project. We are one of the world's best rail companies and the most punctual operation in Europe. On our 3,000-kilometer track network, we reliably transport more than 1.2 million people and over 200,000 tons of freight every day. With our properties, site developments and stations, offices and residential accommodation, operational and production facilities, we make a major contribution to the quality of life in Switzerland, at work and at home. All of this is made possible by the outstanding performance that 33,000 employees deliver each and every day. With the longest rail tunnel in the world, we are proving once again that we have the Swiss qualities of innovation, precision, and reliability, and that our ambitions know no boundaries. With new technologies and digitalization, developments in the field of mobility are gaining momentum, but so is uncertainty. Competition between transport providers for a place in the mobility chain is intensifying. Our overall operating costs are rising, public funds are growing scarcer, and other modes of transport are getting cheaper. New technologies let us take quantum leaps. We are increasing efficiency and punctuality and aiming to stay ahead of the environmental curve. In doing so, we focus on rail's strengths: good value for money for our customers and the affordability of public transport for ordering parties, the Swiss Federation and the cantons is a major challenge that has to be met now for the future. Our mobility of the future must be simple, because our products and services are not yet simple enough. Our mobility of the future must be personal, because our customers want more personalized service in all areas of their lives. Our mobility of the future must be connected, because it's impossible for one rail company to keep everything moving on its own. We want to take on all these challenges with motivated teams, with our true spirit, the legendary passion of railway workers, and with plenty of positive energy. Together, we are turning today's vision into tomorrow's reality. Rail excellence and shaping the mobility of the future. Simple, personal, connected.
Simple, personal, connected. SBB is making great efforts to achieve these goals. But the conditions for achieving this are becoming increasingly difficult. Rising numbers of passengers, more dense use of the rail network, construction sites and maintenance work, just to name a few. In order to meet these increasing challenges, our employee planning needs to be more flexible and automated. We are meeting this challenge with SOPRE, which is the Swiss Railways Employee Planning System and stands for Simulation, Optimization and Planning of Resources. This enables us to manage 1.3 million passengers per day, 10,700 passenger trains. We have the densest rail network in the world, and 5,800 train drivers and train attendants. Our planning philosophy is based on rolling stock. When we know which rolling stock is on the track, where and when according to a timetable, we can determine the necessary crew services. These are then combined in tours. What is a working day on an employee? The main challenge here is to comply with the legal requirements. The staff must meet certain conditions in order to be able to provide these services. For example, knowledge of the vehicle and the driven route, or compliance with the rest periods. We handle all the employee planning activities in only one system. With the yearly planning, we derive the necessary crew services for the following year from the rolling stock planning. This way, we know how much capacity we have to plan for the staff. About 100 users work on it and generate about 120,000 transactions per day. They form about 5,600 tours with, for the operation of 9,000 trains. This planning must be adjusted throughout the year. Here special trains for major events or diversions due to construction sites are included in the planning. Also the changes in rolling stock. Approximately 55 employees managed about 240 events which cause additional traffic on the route network. This requires about 900 additional trains per year. This means that over 40% of the tours from the annual planning must be adjusted. Depending on the rolling stock used, the staff is now allocated to tours created in the yearly planning. Many legal requirements and also holidays and other absences must then be taken into account here. We engage 140 employees for this work. They generate approximately 34,000 transactions in the system and handle 2,500 train drivers and 2,200 train attendants. But the biggest challenge is the operation day. This is the period during which the system is most in demand. because changing in planning can happen every minute. For example, a train breaks down or has a longer delay. In our dense rail network, 5 minutes are already considered a longer delay, which can lead to a change in scheduling of personnel. Therefore, we have a team of 250 employees, and the system execute about 100,000 transactions per day. The complexity becomes clear here. Imagine planning as a spider web. Each station in the network and each driver or train attendant represent a node. The knockout of one node affects many other nodes. Some events we can plan. We know when an employee is sick or on vacation, for example. We also know where we have construction sites or where diversions are planned. Perhaps the staff originally planned cannot drive these new routes due to a lack of knowledge, or maybe a different type of locomotive will have to be driven and we will need a different driver. But we are very good at dealing with just foreseeable changes in employee planning. But what if everything happens in real time? In addition to the change that can be planned, the operation loads the system with events that cannot be planned. A locomotive can be defective. Someone suffers a medical emergency. A track breaks or there's a landslide. Depending on where something like this happens in the network, the effects on the planning are minor or very huge. Often we have to replace stuff, which of course means this has to comply with the above mentioned legal regulations. In reality, such things happen all the time and several times a day. This extreme dynamic in our network demands SOPRE enormously in real time. For a better understanding, I have some examples for you. The first is a track closure. For this example, we take a look on at a train from Geneva to St. Gallen, which travels across Switzerland. The train takes about 4 hours for this route. The Achilles tendon of our east-west connection is the high-speed line between Bern and Olden. Around 250 trains run here every day, and up to 12 trains run at the same time on this 45-kilometer route. This means they have a time interval of 2 minutes, and that on a 200 km per hour speed.
You mean we are nearly at a metro speed?
Yeah. Let's assume there is a personal accident happened on this route. It's not a rare incident. Because of the line closure, the train in Olden will have a significant delay. And if Operations Center did not react, the problem will increase at every next train station. First, the train has to be diverted to another route from Bern to Olden, and will therefore be at least 30 minutes late. That's a lot in our dense network. In order to minimize the impact on the timetable in eastern Switzerland, a new train is therefore being used in Olden. Here you see a workstation in our Operations Center. Of the 8 screens, 4 alone are necessary for SOPRE. At the top right, you see the screen for the rolling stock. On the far left, the movements for the individual trains are shown live. To the right is the information system for the trying stuff, and at the bottom left is a screen for personal applications such Outlook or so. In one control center, there are on average 10 such workstations, and they are occupied 24 hours per day. At this place, the employees must master the current operating situation for 8 hours and to communicate with the colleagues on the trains and in the office. Really not the easy job. In our example, in the operation center, the employees received the first informations about the traffic control system and ALEA. ALEA is an information system in which the train crew and the operation team record observations on the route, at the stations, or on the trains. It's also with only with messages. Almost on the same time, the rolling stock planning deliver changes because a new train is needed in Olden, as I mentioned before. Depending on the availability, this can be a different train type than the delayed train. And then, of course, a new train driver is needed. However, we don't have train drivers in reserve at every station, every train station. With the help of the planning system, a train driver must be found who fulfills the following conditions. He must know the route to St. Gallen. He must have a driving license for this type of train. He must be available for the rest of the journey, and he must have complied with the legal rest periods. The same applies to the train attendants. These are also needed again, because it's a new train. In addition, the newly appointed colleagues must be informed about the new tour. This is done over the phone, and they can see the details in the mobile app. Such or similar scenarios happen several times a day across Switzerland, and that's why a very powerful tool is needed to manage this. Let's come to the next example. Of course, it also happened with us that a train driver overslept. Normally, every train driver reports that he is ready for duty before setting off. He has to do this with the mobile app up to 15 minutes before departure. In SOPRE, there is a list in which the operator can see if someone has not reported yet. If someone is overdue, at first they will try to call this colleague. If they can't reach him, or if it's clear that he will not drive the train, a replacement must be found in the system. This is not so easy, as the same conditions apply as in the previous example. The driver must know the route, he must have the driving license for this type of train, he must be available for the rest of the journey, and he must have to comply with the legal rest periods. Okay, let's go to the next example. That is very current. Is a current example in the lockdown to Corona. Switzerland was also massively affected, and this time home office was ordered, and therefore there were massively fewer commuters. Of course, there were also far fewer tourists, and we also had a lot of sick leave from colleagues. In order to limit the financial impact, the timetable has been reduced to 20%. That's a lot. Most of the trains had to brought to parking lots, which changes the current timetable massively. In addition, the work schedules for employees have been reduced too. We need 2 weeks for this work. After almost 5 months, the lockdown was lifted, and now the trains were needed again. It was much more time consuming to restart the timetable after the lockdown. The pocket trains were taken out of the parking lots within 8 weeks. But with such a long time, so-called stand damage can occur like a plane. Therefore, every train had to go to inspection first. And since train cannot overtake each other on the same track, it was an extreme logistical challenge to arrange this in the shortest possible time, with the appropriate staff, of course. That was the most impressive assurance test for SOPRE. Our business has confirmed that without the system, it would have taken months longer to restore the normal schedule. Another example is the contribution of a good planning system to employee satisfaction. At SBB, every train driver or train attendant can also influence his or her work plan. This leads to a better work-life balance because work and leisure time or family can be better planned. They can request changes to the work plan either directly with the planner or with the mobile app. For example, vacation, absences due to weddings also, other start or end work time, or they can swap their tour with colleagues. The planner checks the request in the system and approves or rejects it. If the request is approved, the system automatically adjusts the planning. And if the automatic process does not lead to the desired result, he has also the options of making manual corrections. The revised tours are then sent from the system to the mobile app, and the employee can see his updated planning, and he's happy.
So I suppose that you have made that evolution of preference consideration with collaborating with trade unions, with representative personnel. It has been certainly a complex element of the systems to establish.
Yes, we have a lot of rules to fulfill. For example, how long has to be a pause or break. There are a lot of rules from the unions, and they control this, that we fulfill this. And we have to build this into the system, and so that the system automatically check these rules, that we don't have any mistakes with this, because otherwise we get problems with the unions. And it's also for the employees that we do this, that they are satisfied with us.
And so the complexity of labor rules, I don't know the Swiss case, the French case. I know it's very complex. I suppose this is similar to in Switzerland. And,
it's very complex, and we have also different personal groups in our system. So the log drivers, then we have the shunting. These are the people they are in the train station and connect the trains together or separate them, and they have other rules. We have also daughters. These are smaller companies. They also in the systems, and they have even another rules. So we have to fulfill, I think, 4, 5 time systems with all the rules. And this makes the system very, very complex.
Okay, I see.
Good, for all this, we need a highly available system. With the appropriate hardware, we are sure to operate 24 hours and 7 days. We need an import from the rolling stock planning every 5 minutes to ensure that the data are always up to date. Or our data from the timetable is updated every 3 minutes. These are huge data transfers. But this way, we can adapt our planning in real time to changes in the timetable or rolling stock. Of course, the following financial processes must be always supplied with the correct data, as I mentioned, the different time systems. A stable hardware is required to operate such a complex system safely. To ensure reliability, we have distributed our system in over 2 data centers. But the software must also be maintainable without any interruptions. Despite the high complexity, we make updates while the system is running, because the highest priority is stable, uninterrupted operation. Such a system is naturally in constant motion. Legal rules change, or the business has new requirements. We are therefore constantly developing the system in order to adapt it to the needs of railway operations. What we have learned painfully: the business process must be adapted to the standard software. Otherwise, you don't need to use standard software. Don't understand the effort of change management. With us, it was enormous, and we are still in it. The learning process of employees is a hard piece of work. Planning in real time is a big challenge for the employees, for the organization, but also for the system. The significant amount of hardware places high demands on maintainability. We are currently introducing the optimizer for further improve efficiency. It helps us to automate business processes and make them more effective. This enables us to save time for planning and to reduce our shortage of train drivers through more efficient shifts. In the future, we also want to automate our functional tests in order to improve our time to market. This way, the business has features that are needed faster. This all means a reliable running system is essential for the SBB. With SOPRE, we guarantee it. Thank you.
So this was a very interesting presentation of DELMIA Quitting in Action at Swiss Railways. So now let's have a look more globally of how DELMIA can help improving rail operations efficiency. But before going there, I wanted to introduce to you the 3D Experience platform and the global offer of Dassault Systèmes and how it helps improving railways. So in Dassault Systèmes 3D Experience platform, we have several types of applications and brands to serve different purposes. First, one is about data analytics. So we have Exaline and NetVibe, which allow us to create intelligence from data and to do advanced analytics, which helps in many domains. We then have social collaboration tools with Innovia brands in particular to make project management, to facilitate ideation of new ideas and management of those new ideas, to establish and manage communities and establish collaborations between people and silos. The original positioning of Dassault Systèmes was about CATIA and the 3D models, but we have many solutions to model different levels and different objects. The cities, the buildings, the systems, and the services, by the way, and all the mechanics and the materials. We can then simulate different products and services at different levels on different subjects, like, for example, the electromagnetics or the behavior of software or the multi-body physics or aerodynamics, and have an experience of those products and services. Then comes the DELMIA brand, which allows us to describe the manufacturing processes, the building also processes, and the operations, and to orchestrate, plan and orchestrate the operations, and in particular, the railway operations. We'll see that later. So with this, we can cover a large span of problems for smart mobility operations in white. First, we can model and capture the requirement for mobility at the level of the city of the territory, and capture the sentiment of the travelers, capture how the evolutions of the population will put requirement for mobility, and how infrastructure will evolve in front of that. We can also design new mobility services and make an experience in advance for the passenger of those new mobility services. We can also validate and certify the new mobility systems, especially when they are made of complex automatic systems, like for example metros. We'll see that later. Then we plan the core of the mobility in the city and the territory, the public transport. And for that, we have solutions to generate timetables, optimize the timetables, optimize the fleet plan and the crew plan. Now, other services like on-demand cars or taxis or e-scooters can be planned on top of that and regulated by the cities, and we help to do that with our solutions. Going closer to the operations, we now make the detailed schedules of all the operations for public transport, so the services at a given time, the fleet and the crew. Then comes the day of operations, and we also have solutions for the three levels, service, fleet, and crew, to manage operations. We divide in that layer. We also have solutions to dispatch and optimize on-demand transport systems. On-demand taxis, for example, jet taxis. And last but not least, we also can optimize, plan and optimize the management of the fleet and the assets and their maintenance. So this is this wide set of solutions that we can provide to optimize mobility in the city or in the territories. So this does, for example, help for railways, the deployment of advanced train control systems. So here is an example where we have complete models of CBTC systems for metro, for here the French metro, where we have the full virtual model with lines being models, the signaling system being models, the driver behaviors is model, and the rolling stocks, and also the central controlling rooms and so on. And this virtual model gives us a real-time simulation on which we can plug real hardware that we want to deploy later, and even the future software, test it and certify it was working well before deploying it in the lines, and saving like that physical test and blocking the lines for nights, for example, in order to do that. And this is used by operators like RATP, SNCF in France, and also the rolling stock manufacturers are using that to validate their embedded software in the trains. We also have solutions to improve rolling stocks health and availability, which basically are to improve the collaboration between the operators and manufacturers. What happens is that when an operator requests for a new rolling stock and is purchasing a new rolling stock, he will express some requirements, and those requirements will be transformed into functional and logical structures, and then turned into detailed design, mechanical, electrical, and software. But what is also designed is the maintenance. It's very important because maintenance will be performed maybe by the operator. So, and what will be designed is what are the spare parts, what will be replaceable, what we call the service board. What are the tasks for maintenance that can be achieved, and how. And how reliable will be the system at the end by doing this analysis, this RAMS analysis, which allows us to measure the level of availability we should reach. Then that is documented with some documentations that will be provided to the maintenance operator. And then the operators come in the line and will do the planning of the maintenance. When doing the rolling stock plan, it will cater the time for maintenance and position that during in the full rolling stock plan. When the rolling stock is arriving in a workshop for maintenance, then we optimize the task scheduling for this rolling stock and all the equipment that has to be used to achieve as quickly as possible those maintenance operations and avoid blocking the rolling stock for too long. Then we facilitate the execution itself of the maintenance operations with DELMIA Priso, which provide seamless communication with the operators and the machines, and by the way, provide the documentation that has been created here to the operators. And also allow us to capture feedbacks of the maintenance operation and on the health of the rolling stocks that can provide us and create global maintenance dashboard, which can be shared between the operators and manufacturers and allow us to check if the requirements and availability announced are indeed there. Last but not least, thanks to those information capture at maintenance time, and also the sensors and information we can receive from the connected cars. We have solutions with Exalead to make predictive models, helps us to decide when we should do the maintenance with a predictive model approach and conditional-based maintenance. Now, let's refocus on crew planning and scheduling. So, what are the challenges we have to address there? We have to address the complexity of the situation. The complexity of this problem is huge. We have the complexity of the crew, the certification, the complexity of the labor laws, the complexity of the safety rules, the fact that crews are in several locations, and we have all the structural constraints which create inefficiency that we cannot avoid. We have to minimize the fact that we have to wait for the train to depart before driving the train. We may have to move crew without them working, to start working at some point in time. So this creates low productivity, low what we call footplate time, and also generate in some cases the need for a crew personnel to sleep out of home, which is not very efficient and not very pleasant. And we are facing an organization which have limited flexibility. By definition, we need to be fair. We need to ensure that everybody feels fairly handled, and so we have a tendency to follow regular cyclic approaches. If we take now the point of view of the crew, well, it's not easy for them. They are suffering the constraints. They are not always have their ideal work-life balance. They have to sometimes to sleep out of home. Their preferences are not always considered, and they are not always able to self-organize. For example, to exchange a shift with somebody else. And they don't have all the visibility they would love to have on their schedule. Now, us, the customers, the passengers, or the freight forwarders, well, we will benefit from better service quality, better punctuality, and also service maybe more in line with what our need in terms of timing and volume. And also sometimes visibility on train services is not ideal. So these are the challenges that we have to address with our solution. So how do we do that? So we have first a crew planning, so long-term for the forthcoming period solutions that to create anonymous rosters. So first we create shifts, which is a day of work, and then we put those shifts in sequence in the cyclic rosters that will be assigned to a team. So that's what we optimize first for the forthcoming period with CRO. Then we go to the scheduling, so which means we make nominative schedule for each activities that are needed to serve the trains by assigning the master rosters line to people and adjusting them. And then we arrive in the day of operations, and during the day of operations, we have to cater for all the disruptions in an efficient manner in order to be sure we keep the service quality high and avoid costly situations. So if we first look at crew planning, what are the key questions that the planners have to answer? So first is how can I group the different service activities in working days, what we call shifts, without having too much inefficient time or waiting time or pass ride, movement from between two stations without working that may be needed. So that's the first thing. And then to put that in sequence, days after days, while obeying all the rules, number of weekend of rest or rest between 2 days, and being efficient. That allows us to measure how many people are needed in order to cover the timetable of a given period. So indeed, if it is less efficient, you may need one extra driver, for example, or two extra drivers. So it costs a lot. That, by the way, this can help answering some questions like optional services. You can imagine that catering is not needed on all trains, and the decision to put catering services on a train can be done better if you measure how efficiently it will be covered. So maybe you will not put a catering personnel on a train if this catering personnel arrive on station in Nice at 10 a.m. and then have to wait 6 hours before having another train to serve. So this will not be done because of that. So you will optimize the service plan, measuring the number of people are needed and the efficiency of the plans using these tools. So this is again made of two processes, shift planning and master roster creation, served by KPI-based planning and optimization capabilities. So I will show you that in action with a solution. So the solution that we have first starts from the timetable. So here, presentation of the timetable for a given period in DELMIA Quintic. And for each of the train, you see the different legs that will be covered by the train. And this creates activities, crew activities, drivers activities, which are there, that then have to be assembled in a sequence, a day of work. So that's what we are currently doing here. So helped by the DELMIA Quintic, we are creating a day of work, chaining activity for drivers, and we are helped with alerts about constraints which are violated, and with KPI showing how efficient we are in terms of productivity and what are the part of the requirement we have done. But best, we also have optimization engine which create automatically a solution with all shifts covering all requirements, optimizing the productive hours as much as possible. You see that there could be some complex stuff, some inefficient time, like what we call past ride here. We see all the constraints, both labor rules and physical constraints are obeyed. Once you have created the shift, you need to assign them in a roster. This is a roster, and you make a sequence of work, a sequence of lines for a team. So this can be done by hand with help by the system, but also through an optimization engine, which will optimize the different criteria. Here the criteria is mainly are we sure we are covering all the shift and obeying all the labor law rules. So this is what is done here by the optimization engine. So thanks to that, you can ensure efficient plans. Once the plans are done, you have to go to the scheduling aspect. So scheduling, it's months, week ahead, and you have to answer several questions. First, the questions about leaves. I mean, you need to know who will be there and to control who will be present or who will be in leave during the period. And you have to be sure that even during a highly demanded period, you will have enough drivers. Then you also have questions about certification. If you don't have somebody available, if you don't have a driver working on a given line, he will lose his knowledge of the line. So you may decide to assign the driver on the line to maintain its certification. It's an important decision here. Then what is done is you should first assign the rosters that has been built during the planning phase to everybody, to each, and then you decide which part of the roster will be done first by each drivers or each crew personnel. It has to be compatible with its previous schedule, and it also has an impact on how best we manage its preferences. So, for example, we can have a bi-weekly Wednesday off preference for somebody that is better covered if we assign line number 2 of the schedule of the rosters in the first week of the period. But that is not all, because this is only the schedule of the train services are changing. during the period, and there are many exceptional services that has to be catered for. And for example, you have bank holidays that happens and will perturbate the service, create new services, and you have to cover that in the schedule. So this is a complex and solutions that is doing that. So with leave planning, certification management, roster assignment, also provide the employees the ability to request the coverage of the shift and even swap shift with another employee, and then having a continuous optimization and rework of the rosters. Let's have a look to that. So the starting point of the solution is a solution, the mobile solution provided to the employee that allows him to access to the schedule as it is up to now, and also request for leaves. So here is requesting a new leave, and this is then sent to the central planner, who has prepared the work by defining what we call leave slots, so the number of people that are allowed to be on leave at a given point in time, and he has a maximum number according to the anticipation of the need. So we'll accept or reject the request based on the availability of those leave slots. And so this is done held by the system and automatically then inform the employee thanks to Critique. Second steps, you are managing the roster. So here we have the rosters, the full schedule, and you see the leaves that has been accepted, and you see because of this leave being accepted, you have some unassigned shift that has to be re-given to somebody else. So you need to find somebody else. So you see some reserve employees that can be used here. There was some place, but you can also ask for to the system who could be assigned to the shift. And we have an automatic set of proposition, and we can also be helped by the system to call and to track the approval from the employee to cover a given shift. The other way around is the employee can request to work on given shifts. So this is really a two-way communication. And so here he's requesting to cover a given type of shift for some days. And this request is sent to the central planner that can accept or not the request, as you can see here. So there is much more here, but you can have a glimpse of how efficient is these tools to establish seamless communication between the employee and the planners for them to be aligned on a schedule which follows their preferences and cover the requirements. Now let's go to the operations. When we go to the operations, the questions that we are now during the day of operations or just before the day of operation, and we have to react in hours or even minutes sometimes to disruptions. So typical example of question we have to answer that was shown by Rene before is a driver is missing this morning, how can we replace him? Or there is a problem with a fleet schedule. There is a train unit which is broken. So this creates new activities. We need to fetch the new train in a depot to replace this one. So this is new driver activity that has to be covered. Now there are also perturbations, which are typically a service being late. So when a train arrives late in a station B, then the driver were supposed to take another train and drive another train from B to another station C, may arrive too late. So either you delay the other train just because of the driver, maybe not good, or you find an alternative. So basically, when you look for alternative or how you can work, who can work on what, well, you have several options. You can use overtime. You can use standard personnel. You can use reserve time in existing shift, but also people that are standby and call them for work. And you also can call for people from other depots. Maybe it would be costly because they will have to come there, maybe in taxi or pass ride on another train. but it may be a good solution. So there are a lot of possibilities, and you have to find the best one in a very limited amount of time. So you need a very efficient and reactive tool for that. So this works like that. So we have a solution. So here again, Quintic. You see all the activities that are not assigned. You see the current schedule. You see alerts when there is a problem. You see when the KPIs that give you the work to be done and the quality of the current schedule. So you can react quickly, monitor everything. So you have all information being up to date. So you import regularly the situation in the tool. So you know when the train is late, for example, and when a crew is missing. And you have tools to facilitate the discovery of alternatives and find the best compromise between service quality, between the crew cost. And you can also try to reduce the domino effect. If you change the planning for one staff member, you try to avoid having hundreds of staff members to change, so you reduce the domino effect. And you keep everybody well informed of the change and the impact of the change. So this is what is providing DELMIA Quintic. So why do we are sure that DELMIA Quintic is a good solution for crew planning? There are many good reasons for that. The first is, okay, we have with DELMIA Quintic done a lot of complex workforce planning problems. For example, the air traffic controllers have complex planning problems with complex union rules, and also many railway companies are using our tools for workforce planning. So also very complex union rules, complex planning processes. So we are leader in this domain with many needs. With DELMIA Quintic, we have a philosophy of giving the planners the power on the solution, on the plan, and give them the tool to visualize the solution and the problems, to interact with the solution, to try solutions, and collaborate with other people, other planners if needed in real time. And it can give them the capacity to really see what is the best balance between the different KPIs, which are always conflicting. We also have advanced algorithms for optimization, so we can very quickly provide good solutions, or search for good solutions with advanced algorithms. And we also have real-time propagation of any information and of all the decisions we take to be sure that all the relevant stakeholders of people that needs to know something about the decision being taken or the perturbation that has been that happens are communicated. Last but not least, we have with DELMIA Quintic, we have a single integrated solutions which covers the full horizon from long term to short term, and also can be shared between all the different stakeholders, maybe station people, fleet planning people, and crew planning people. So this is why DELMIA Quintic is a successful tool for crew planning and in general for rail operations planning and optimization. Thanks for your attention.
Thank you. Now it's time to start the Q&A session. Thank you for submitting your questions. We have received a lot of feedback, so if we run out of time, we will follow up individually with those of you whose questions we didn't have a chance to answer today. Alternatively, please send an email to our event email address, which is visible on the screen. Now let's get started. I'd like to thank you for joining this session today and encourage you to complete our online survey about this event. This will help guide us in developing even better content for future events. I'd also encourage you to check out the reference sites listed to learn more about DELMIA and our solutions, find out more about our customers and their success, and schedule a meeting with a DELMIA representative. Please check out our other sessions being broadcast this week as part of the DELMIA Operations World Tour 2020. These are cross-industry sessions with a lot of interesting content, including special customer presentations. I know that you will find the time spent to be worthwhile. With that, I'd like to say thank you for your interest and attendance and wish you a very pleasant day.